Okay. Geometric sequences. Our goal is going to be to look at a sequence either in a table or a list, write an equation, and use it to predict other terms later on, just like we did for arithmetic. Okay. The equations are going to look different, but we're going to use a lot of the same kind of ideas. So let's go ahead and start off with an example, just like we did with arithmetic. And for our first example for geometric, we're going to do a table as well. So we'll do n and t of n. 0, 1, 2, 3, 4. And my terms are 7, 21, 63, 189, 567. Okay. So first question is, how do you know that this is not an arithmetic sequence? We're not adding the same thing over and over again. From 7 to 21, that's 14. From 21 to 63, that's 42. We're not adding the same thing each time. So then we would need to check and see if we're multiplying by the same thing each time. If so, that's what makes it a geometric sequence. Remember, a geometric sequence is something where we multiply by the same value to get the next term. What do you multiply 7 by to get 21? 7 times 3 is 21. Do you think that's going to work to get us from 21 to 63? 21 times 3 is, oh, look, 63. I wonder what 63 times 3 is. Anyone want to predict? 189. Oh, look at that. And I bet if I took 189 and multiply it times 3, I would get 567. So we have found that to get from one term to the next, we're multiplying by 3, not adding this time, but multiplying. And that's what makes it a geometric sequence, multiplying by the same thing over and over again. This is called our common ratio. So it's no longer a common difference, it's a common ratio. Okay. So are we fairly comfortable still with finding T0 and say T3? Show me that you're still feeling pretty good about that. It's the same way you would have done it with arithmetic sequences. T0 is the 0th term. What is the 0th term of our sequence here? The 0th term is 7. And T3 would be the 3rd term of our sequence, which is 189. So nothing changes there. The big change is going to be with the equation. So the equation is going to look quite a bit different here. Let me show you what the format's going to be. Still going to be T of n equal to. You're still going to have two numbers, but at this time it's going to be one number multiplied times another number to the n power. Now think about, what does an exponent do? An exponent causes something to get multiplied over and over and over again, right? So what number do you think we're going to put in this parenthesis here? What number is getting multiplied over and over and over again in our sequence here? We're multiplying by 3 over and over again, aren't we? So the 3 is going to go right here. That's our common ratio. And then we've got another number that's going to go right here. Does anybody want to make a guess what that other number is going to be? What do you think? It is going to be 7. Yes. The 0th term makes an appearance again in this equation. It's in a different spot now, but it does show up in the equation. So again, if you're a fan of arrows, go ahead and draw some arrows so you've got a record of where all this stuff is coming from. The 0th term is the number that multiplies in front. And then the common ratio is the number inside of the parentheses. If we wanted to now, we could use that equation to predict what the 99th term is going to be, but we're not going to do that. Well, we could try. I'm going to show you what's going to happen if I plug 99 into this. It's going to be 7 times 3 to the 99th power. And if I were to write this out, this is going to be a 1, 2, this is 10 decimal places, and then I need another, let's see, I would need 48 decimal places after this one. So I would need these 10 decimals plus another 38 zeros at the end of it. Is a huge number. Okay, so we're not going to do that. We could go, let's go ahead and predict what the 6th term is though. Let's do T of 6. If I wanted to find T of 6, then I would do 7 times 3 to the 6th power. Could I get you guys to all type that in on your calculator? Let's make sure you know how to type a exponent in on your calculator. You're going to use this button right here. Look for a button on your calculator that's got, it looks like a little upside down V. If you don't have that, you might have like X to the A or A to the B or something like that. 7 times 3 to the 6th. The number you're hoping to get is 5103. All right, let's draw a little wall here and then we'll do one more example. This time I'm going to give you the numbers in a list. Leave a little space here because we're going to want a space for a 0th term. Our first term is 300. Second term is 360. Third term is 432. Fifth term is 518.4. And that's as far as we'll go. Keep in mind that's our first, second, third, fourth terms. We are going to need a 0th term eventually to write our equation. But the first thing we're going to need to do is figure out what our common ratio is. Can I get you to take notes, please? We're learning something new. Yep, we're doing another example. So let's focus on that instead of doing homework right now. Yep. You got this one in your notes? Okay. All right, so common ratio. Anybody want to weigh in on this? What do I multiply 300 by to get 360? No? Not sure? How'd you get that 1.2? You just kind of guess and check? Or did you do something else in your calculator? There is something you can do in your calculator to get. The answer is 1.2. What could I do in my calculator to get 1.2? Awesome. Okay. I need you guys, you're going to want to write this down because this is something that you're going to end up doing quite a bit. To find this 1.2 right here, and I'm going to draw a little thought bubble coming up here. To find that 1.2, you're going to pick 2 of your values. You're going to do the second one divided by the first one. It doesn't matter which 2 values in your sequence you pick. So we picked the first 2 here, 360 and 300. You do the second one divided by the first one, and that's going to give you your common ratio. This is my little thought bubble coming up here. That's where I got the 1.2 from. So we used the 360 and the 300. We could have done the 432 and the 360 also. 432 divided by 360 is also 1.2. Or I could have done the 518.4 divided by 432. Any one of those that I divided, I would have gotten 1.2. But you have to make sure you're doing the second one divided by the first one. Okay, awesome. All right, so now that we know it's 1.2, we're going times 1.2 times 1.2 and so on. How are we going to back it up to find the 0th term? What's the opposite of multiplying by 1.2? This time we're going to divide by 1.2. So take 300, divide by 1.2, and that'll tell you what our 0th term is, which is 250. So our 0th term is going to appear in our equation as long with that common ratio, which was 1.2. So let's get ready to write our equation here. T of n equals, it's going to be something times something in parentheses with a power of n on the parentheses. Look at the last one that we just did and see if you can figure out which one's going to go here and which one's going to go here. We've got 1.2 and 250. Which one goes where? So our 0th term is going to go here, which was 250. And our common ratio is going to go here, which was 1.2. All right. So we're going to be focusing on Thursday on writing equations for geometric sequences and arithmetic sequences. So we'll practice both. I'm going to give you a little bit of practice to do, and then you're going to have a large chunk of time to work on the homework assignment. Just in case anybody is looking to get out ahead of it, this will be our assignment over spring break. What? Yeah, that's right. I'm going to give you homework over spring break. You deserve it because you're good people. Yes, yes, you are. And handout. But you're going to have the majority of the period to work on that. Okay, you got a handout and you've got how many problems? 6 problems there. Those of you who are utilizing your time well, you're going to get that finished in class on Thursday. That's why we just did our notes early. Can I what? Like that? Other way? Like that? You're welcome. All right. Thank you guys for your attention, your hard work today. 2 lessons in 1. You're awesome.